That's all.
Well, you're right here, so I'm really not trying to put words in your mouth. I mean, I want to know, what were you surprised about? Why did you tear the thing back down? Because if I do make it, I don't want to make the same damn mistakes. But I did want to point out that you are drawing current from the ground. You might, but if you ground them all together, that could be canceling most of it out.
You're not drawing current from the ground, Brian.
Okay, you're not drawing current from the ground, Brian. You're not drawing current from the ground, Brian. Okay, that's his first claim. Okay. Now you're drawing a charge, and if you have two plates connected to the ground with a copper wire, and they get in proximity to each other, then you are drawing a current from the ground, as I demonstrated. Okay, and even if you have the two plates grounded together, okay, on the same grounding rod, you're still drawing a charge out of the ground. I'll give him this. Okay, hold on.
Draining static charge off to the ground is what you're doing.
So he says you're grounding the static charge off into the ground. I'll give him that, okay? I'll give him that, but not the electromagnetic charge, okay? I don't know if he's being willfully ignorant and just not, or maybe he doesn't understand. Now, if he understands and makes these claims anyway, then he's a lying, rotten piece of shit, okay? If he is. Now, if he doesn't understand it, and he's making claims, okay, that are wrong, then he's not lying. He just doesn't understand, okay? So I'm not gonna just call him a liar, and I'm gonna let you be the judge. We're gonna listen to his claims. I'll give him that. So you might be getting rid of the static charge by grounding them together, but you are not. All you're doing, if you ground them together on the same rod, you're polarizing them, and I'm about to demonstrate that. You're polarizing them with a charge. Okay, so let's hear his other claims.
Okay, do you want me to show you again?
You want me to show you?
Brian, I'm going to do this.
Brian, I already know that you don't understand any of this. That's fine. I don't need to say it again. I realize you don't understand it. That's fine.
If I could give me about 3 minutes.
So I don't understand it. I don't understand. So that's his third claim.
If I could put my camera, if somebody just wants to look at my page, I got the lead hanging up, and I got the rod grounded.
Quick question,
You're
Brian.
just going to show us you don't know how a multimeter works. You don't know what a high impedance input impedance meter is all about. You don't know how to use one.
It's a regular multimeter, Blue.
So I'm gonna show him that I don't understand what a high impedance multimeter is. Blue, I don't know of any multimeters that are not high impedance. I mean, I'm sure you're not making that up, but I mean, they're all. I mean, high impedance just means it's more sensitive, man. There's a contact or a node or some shit in there that's more sensitive to volts. It'll read more, whatever you want to call it. And a multimeter is a simple tool. I've been using it my whole damn life, man. It's you have your different settings. Okay, you have. I mean, he asked me, what is impedance measured in? Like he's gonna call me out, like he's gonna catch me out. I'm like ohms. So you have your resistance, which is your ohms, okay? Then you have your voltage, you have your AC and your DC in different settings, okay? You have your current, okay? If you have, I mean, it's Ohm's law pretty much. The volts equals the current times the resistance. So if you could figure any of them two out, you can get the other one just by calculating it, Just solving, it's a simple equation. V equals IR, I think. But, you have continuity also. So that's probably the most handy setting. It's the one that beeps. You check for a connection. So if you want to see if something's disconnected or not, you hold the positive and the negative lead to the meter, to the wires or whatever it is you're testing for connection. And if it's connected, you get a steady beep sound. But I mean, I understand what a damn multimeter is. I mean, it's just. I'm going to show. Let me demonstrate so we could figure out, who's wrong and who's right.
Rocket science, bud. I can measure the capacity.
Hold on, you don't know what, you don't know how to.
I mean, okay, so here is the meter attached to the, it's set on a 9 volt, 0.01, it keeps going from 0 to 0.1, okay, that's to the plates that are not grounded, okay, these two plates are not grounded. See, there's the black clip to that one, there's the red clip to that one, and here's their wires just hanging. They're not grounded, okay. Now I got these two plates are grounded, okay, there it went to 0. It jumped down to 0, okay. Now here's the two plates that are grounded, okay. And what you got is a mess. No, but nothing's touching metal. Okay, so this one is going to this copper pole, or copper rod about 6 foot in the ground, and the other one's going to that piece of rebar that's about 12 foot in the ground. Okay, now I'm gonna switch it over. Here, do that so you can see better. Okay, so it should be switching it over. So I'm gonna switch these over to the two that are grounded. And there you have it. 0.17, that's measurable. Just to double check, I'm gonna just try it with this voltmeter just to see. Just to see if it's consistent. Okay, what's that voltmeter say up there? 0.17, that's consistent. That ain't no high impedance shit, whatever. It might be more sensitive, but Blue says you're not getting current from the ground, Brian. Okay, now I'm gonna also show you something else. Okay, so there it shows you're getting it from the ground, and sometimes it's a little more, sometimes it's less, depends on what material you're using. So up here, right here, I have two lead plates going to two different grounds. Okay, using steel. Look, using this Vulcan flux core welding wire, which is made out of steel. Okay, now what we're gonna do is test that. Okay, and one of them one of them will assume a positive, and one of them will assume a negative state. Okay, automatically every time I do this, and it sticks. So when you switch it, it will show a negative reading. Okay, so here's the welding wires. It's showing something different. Wait, one of them ain't grounded. One of them ain't grounded, so it's barely reading anything.
You ain't got them hooked up.
Oh yeah, no shit. Well, maybe, all right, so might help if you have them hooked up, folks. Just might help a little bit. Got the wrong one hooked up. Well, let me try this one since it's already hooked up. There's a clusterfuck here, but nothing's touching metal or nothing like that. That's the only thing important. Go to 9 volt setting. 0.16, a little bit less, so it's negative. It's negative. Watch. So this automatically assumed a different charge. I mean, so look. So I'm gonna switch these around. Just dancing around. Okay, these ain't grounded too good, but it's almost the same, but it's a little bit different. Okay. I want to show one more thing. Let's see. Let's check it with this meter. Let's see if it also reads a negative when I hook it up the same way. Yeah, It was showing a negative, but it's, yeah, about negative 1 volt. That's what the other one dropped down to. Pretty consistent. But let me switch these. So this should show the negative, I do believe. Yeah, see, there it is. So negative. So one assumes an anode, one assumes a cathode. Okay, that's just the way it works, and it sticks to it. It's pretty consistent. But so look, so we can switch it over to ohms. Okay. So there's 7.3 kilo ohms. Okay. 7.2, 7.3. Let's see if it's the same on this other. So you can figure out the current. Just divide the 7.3 by the 1.6. It's probably about 3 or 4 milliohms, but it's Ohm's law. Okay, Ohm's law is V equals IR. So that's voltage equals the current times the resistance. So if you know two of them, you can figure it out just by reversing the equation. So in other words, the current will equal basically the I is the current. So the current will equal the the voltage, or the resistance over the voltage, or the vice versa if I'm not mistaken. But yeah, if you got two of them, you can figure out anything. You can figure out the resistance if you know the volts and the amps, and you can figure out which amps is the current. But let's see if it's fairly consistent. We'll check. Well, you know what? We've seen everything's pretty consistent. The point is we get different currents for different meters. We ain't getting hardly shit when the wire's not touching the ground. In the daytime I got absolutely 0. Okay, but it's going like 0, 1, you know. But at night it's a little different. I don't know. I don't think everything's fully known with about all this stuff, man. But the point is we weren't getting the current when we're not connected to the ground. We connected to the ground, we got the damn current. So for him to say you're not getting current from the ground, Brian. Okay, now I give him this. Like if I was to ground these two wires, or even all four of them, to the same pole, to the same grounding rod, then yeah, it would zero out. Okay, instantly if I touched them to it, it would also zero out. But it's polarizing. Either way, it's giving it a polarity. So that shows you right there. One of them's positive, one's negative. And actually the steel was a reverse polarity from the steel wire, and the copper wire were opposite polarity. So if he's going changing all these wires, you know, thinking it's just a twist in them and all this stuff. Look, there's stuff he's not even factoring in. This Cavendish it's not an experiment. He's not varying shit. The main force at play here is electromagnetics. Maybe the static. Okay, we get rid of the static if we ground it. But there's energy in the ground itself, and I think I've proven that. So, thank you.